for asking me to take part. Hello, dear colleagues and guests. Let me declare open the session for the Dissertation Board for the Defense of Thesis by Popova Elena on the subject Synthesis Properties and Types of Biological Activity of Tetrazoles, submitted for procurement of the degree of Doctor of Chemistry, Specialty Organic Chemistry, according to the order issued on the 30th of January. Myself, Lemnikov Alexander Feodosevich, Doctor of Chemistry, Professor of Department of Organic Chemistry, St. Petersburg State University, was appointed Chairman of this Dissertation Board. Let me introduce my fellow board members. Bayarsky Vadim Pavlovich, Doctor of Chemical Chemistry, Professor of Department of Physical Chemistry, St. Petersburg University. Vasilyev Alexander Viktorovich, Doctor of Chemistry, Professor of the Organic Chemistry Department, St. Petersburg State University. Ivashkevich Oleg Anatolyevich, Doctor of Chemical Sciences, Belarusian State University. As well, and in remote mode, we have Nenadenko Valentin Georgievich, Doctor of Chemistry, the Moscow State University, named after Lomonosov. First, let me emphasize that according to the federal law issued on the 30th of August 1996 on science and state scientific and technical policy, the St. Petersburg State University has the right to award academic degrees independently. The corresponding order on the procedure for awarding the academic degrees at St. Petersburg State University, on the basis of which we are holding this session of the board, was issued on the 1st of September 2016. In accordance with this law, the session of the Dissertation Board is duly constituted if at least 2/3 of the approved members of the board are participating. That not less than 4 persons. Our Dissertation Board consists of 5 members. Everyone is present, including 1 remote interactive board member. Audio-visual contact to him has been established. Thus, there is a quorum. Let me set forth the procedure of today's session with a total duration of no more than 2 hours. The Chairman's brief report on the main content of the documents submitted by the candidate and their compliance with the applicable requirements. Answers to possible questions, 5 minutes. A brief presentation by the degree applicant outlining the key points of her study, 25 minutes. Questions to the applicant strictly on her report, not more than 5 minutes per each question. Speeches of all members of the Dissertation Board, alternatively with their feedback, with the statement of their positions, questions and suggestions to the degree applicant, no more than 10 minutes for each speaker. This will be followed by the speech of the Chairman with his feedback, answers of the degree applicant to questions and remarks of the members of the Dissertation Board, not more than 15 minutes. Open discussion, speeches of the attendees with a summary of their position or with specific questions and suggestions to the dissertation, strictly on the topic of this study, no more than 5 minutes per person. To do that, all the speakers are kindly requested to put their names on the registration sheet and introduce themselves in full before speaking. Final answers of the applicant to the questions asked, not more than 5 minutes. A speech of the scientific supervisor, no more than 3 minutes. A 5-minute discussion before the open voting on awarding or not awarding the academic degree to the applicant. For the time of this discussion, the broadcast has been suspended. Open individual voting. The Chairman of the Dissertation Board shall count the votes and the results shall be recorded in the minutes of the meeting. A decision on awarding or not awarding the academic degree to the applicant. This shall be followed by the closing remarks of the applicant, no more than 2 minutes. Before starting the official procedure, let me remind you to switch off your mobile phones. Thank you for your understanding. Let me also inform you that our meeting shall be recorded and broadcast online at the university website, and the speeches shall be simultaneously translated from Russian into English or from English to Russian. And now, let us begin with our first item, Chairman's Summary Report. Dear colleagues, dear members of the board, dear colleagues, let me introduce I'm sorry, I violated the procedure. I forgot that I have to list introduce you and list documents that you have submitted. The dissertation of Elena Popova was submitted for procurement of degree of Doctor of Chemistry, specialty 020003, organic chemistry, was accepted for defense the 30th of January. The dissertation board was appointed by the order on the 30th of January 2019, and I have already introduced the members to you. Dear colleagues and guests, the candidates submitted the following documents to the academic secretary: an application to the rector, Professor Kropotchev, to accept the thesis for review and defense, submitted on the 19th of December 2018. A review by the scientific supervisor, Trifonophrastis Evgeny, Doctor of Chemical Sciences, Professor of Chemistry of Natural Compounds, a list of 19 publications describing the main academic results of the thesis, including 19 articles published in periodicals, including the International Database and Citation Systems. Candidate diploma on awarding the candidate of chemistry degree to Elena Popova, as well as the thesis in Russian and English as manuscript and in the electronic form. The thesis has been formatted according to the requirements of the national state standard and printed on a multiplier. It should be noted that all the above-listed documents comply with Article 12, Section 3, Thesis Presentation and Defense of the procedure for awarding the academic degrees at St. Petersburg State University. Appendix 1. And now let me give the floor to the applicant. Dear Chairman, dear guests, and dear members of the Dissertation Council, allow me to present a report on the results of my dissertation study on the synthesis, properties, and certain types of biological activity of tetrazoles. It should be noted that among azoles, tetrazoles stand out for the unique properties, thus having a high content of nitrogen in the heterocycle. Tetrazoles are quite stable aromatic compounds. At the same time, their stability is characterized not only by their resistance to oxidants and reducing agents, but also by metabolic stability of tetrazoles in the body with a very low toxicity. It's this fact that contributed to the recognition of the tetrazoles cycle as the most important pharmacophoric fragment. It's a part of the structure of many drugs with different therapeutic effects. This slide shows some examples of successful application of tetrazoles in medical chemistry. This success can be partly explained by the established view that the tetrazole cycle is a metabolically stable biosteric analog of carboxylic and sesamide groups. Tetrazoles are usually synthesized using reactions of various functional groups, aliphatic and aromatic compounds with azides. However, it must be said that despite their widespread use in some aspects of tetrazole chemistry, there are still many unresolved problems. Thus, despite the fact that various methods of tetrazole synthesis are known, in most cases they require quite harsh conditions of reaction, such as prolonged exposure at high temperatures and high pressure. In addition, the synthesis of tetrazoles in most cases is accompanied by release of explosive hydrogen nitride acid, which is formed in situ during the presidium. In this connection, the development of effective and safe methods of tetrazole synthesis remains an open question, especially on an industrial scale. Besides, it should be noted that tetrazole analogues of a number of natural compounds such as amino acids, peptides and nucleosides were insufficiently studied. Many aspects of the biological action of tetrazoles, including their interaction with the most important biological targets, have not been studied. At the same time, research in this area will make a significant contribution to the chemistry of tetrazoles, increase their availability and expand the range of practical applications of these compounds. In this connection, the aim of this work was to develop effective and safe methods for the synthesis of tetrazoles, including new analogues of natural compounds and biologically active substances, their functionalization and the study of biological activity, including the establishment of mechanisms for their interaction with biological targets. In order to achieve this set goal, it was necessary to solve the following tasks: to develop an effective metal-promotable approach to the formation of 5-tetrazole cycle by means of presidium of activated nitriles coordinated by PT2 and PT4. Develop a safe and effective approach to obtaining 5R unsubstituted 1,5 and 2,5D tetrazoles using microreactor technology. Synthesize several series of practically important tetrazoles such as analogues, amino acids, peptides, nucleosides, as well as tetrazoles containing complexes of palladium and platinum for biomedical research. Study biological activity, antiviral, cytostatic, antibacterial of the obtained tetrazoles, including mechanisms of their interaction with the most important biological targets, such as DNA and proteins. To solve the first problem, we propose a metallopromatized approach for the formation of 5-tetrazole cycle by means of metal-activated neutral presidium. The reactions of neutrals coordinated to platinum and platinum-4 have been investigated. It was established that in all cases the presidium was carried out in both cyano groups with the formation of appropriate coordination zones. In order to establish the effectiveness of this metal-promoted approach, quantitative control over the course of benzonitrile presidium coordinated to platinum-2 azide was carried out. The kinetics of the presidium was studied under pseudo-first-order conditions of the substrate. The pseudo-first-order reaction rate constants were determined by the integral method using semi-logarithmic amorphosis of kinetic curves. Further, taking into account the concentration of presidium agents, second-order reaction rate constants were determined. When comparing the data obtained with the constants of presidium of uncoordinated, it can be seen that transition of the metal-promoter reactions to the presidium speed is not only increased by several orders, but also goes at temperature to issue the classical 1.3 bipolar cycler addition of azides is not realized. Thus, this method is a convenient and effective method of obtaining coordinated 5-tetrazoles. As was noted above, the danger of tetrazole synthesis is connected first of all with the release of explosive hydrogen nitrate, which is formed in situ at presidium. To ensure safety of this process, we proposed to conduct neutral presidium in microreactor conditions. Essential advantages of microreactors are compactness, high coefficients of heat and mass transfer, as well as extremely high safety when working with explosive media. This is due to the fact that the cross-section diameter of microchannels does not exceed 1-2 millimeters, which significantly reduces the risk of detonation propagation in the reaction volume. The installation, so we studied the reaction in a specially designed reactor, and this degrees Celsius carried out. We studied the influence of pressure on the velocity of presidium. It was established that the pressure increase leads to noticeable acceleration of the process. At the next stage of our work, the possibility of using a microreactor technology to obtain N1 and N2 alkyl tetrazoles was studied. The reaction of alkylation of 5-phenyl tetrazole with methyl iodide in two-phase system was carried out. As a rule, such reactions require the use of interphase transfer catalysts to produce. So we carried out this reaction in a standard capacitive reactor with the use of bromide tetrabutylammonium as a catalyst in the effective mixing mode, which was provided by the use of a dispersant with a speed of 3,000 revolutions per minute. So we also call that it is a microreactor without the interphase transfer catalyst. At the organization of such a mode of a two-phase system flow through the microchannel, one liquid moves in the form of elongated shells separated by droplets of liquid of another phase. The peculiarity of this mode is the effective mixing inside and on the surface of such a shell due to the formation of toroidal eddy of Taylor. In the course of research, we found that the accumulation of alkylation products is carried out much faster in the microreactor than in the capacitive reactor in the conditions of effective mixing and application of the catalyst. Thus, the use of microreactor technology in the synthesis can be a very effective and safe alternative to traditional methods obtaining these compounds. At the next stage, several series of tetrazoles analog of natural compounds, such as nucleosides, amino acids, and peptides, were synthesized. Analogues of natural nucleosides play a significant role in chemotherapy. For example, azidotimidine with an azide group was the first approved effective antiretroviral drug for the treatment of human immunodeficiency virus. We used it as the initial substrate for obtaining modified nucleosides. To obtain these nucleosides, we pre-synthesized 1 and 2 propyl tetrazoles were used in a copper-catalyzed click reaction with azidotimidine X-ray analysis. X-ray analysis of the modified nucleosides showed that the fragment in these compounds has a 3 exoconformation as a result of formation of hydrogen bonds between keto and in ash groups of some formation of some is observed. The inhibitory activity of 3 modal nucleosides with respect to human immunodeficiency virus was investigated. It showed that weak antiviral activity in the range of the studied concentrations. The study of the anti-influenza activity of modified nucleosides with respect to the influenza A virus showed that in a number of cases the selectivity of the action of tetrazoles containing nucleosides was higher than that of reference rimetidine. At the same time, it should be noted that all the studied nucleosides showed up very low cytotoxicity with respect to MDCK cells. In order to determine the possible mechanism of action of modified nucleosides by molecular docking, we studied the interaction of one of the obtained nucleosides with the influenza A virus in combination with an RNA primer. The calculated data showed that the nucleoside binds to the PB1 subdomain, i.e. it's located at the same site where the RNA primer is located. Thus, the ability to interfere with the viral polymerase activity is confirmed. Modification of the structure of such natural compounds as amino acids is a well-known approach which allows to obtain new substances that exhibit different types of biological activity. By means of presidium, corresponding amino acids were synthesized. As it is known, the biological activity of compounds containing chiral centers depends to a great extent on their nanometric purity. We determine the values of excess by HPLC method with the use of chiral columns. It's worth noting that the largest excess is determined for the tetrazoline analog of glutamatic acid benzyl ether. In other cases, the value of this indicator is in the range from 20 to 96%. The anti-influenza activity of the tetrazoline analogues of amino acids in relation to influenza A virus was investigated. These compounds were found to exhibit different levels of antiviral activity. The tetrazole analog of has the highest selectivity index with respect to the strain under study. It's also necessary to pay attention to the very low cytotoxicity of these compounds and the selectivity of action. Using L and D as initial substances was introduced into the side chain aromatic amino acids at the position of benzene ring. At the first stage, nitration was carried out. Then a protective group was put on alpha amino function. After that, the nitro group was restored to the amino group, and propyl ether was obtained, and the amino group was preformed, which allowed introduction of a tetrazole fragment. After hydrolysis of the ether group and removal of the F mark of the protective group by the can be used for the synthesis of peptidometrics and other practically important compounds. Also, we synthesize analogues aliphatic amino acids containing tetrazole fragments in side chains instead of delta in epsilon amino groups, respectively. We use the FIMOC-protected tetrazole analog of alzyne in the synthesis of the analog of the cyclic octapeptide analog of octreotide. The octreotide is an inhibitor of the growth hormone and insulin. A significant disadvantage of this drug is its relatively low resistance in the body. It's known that the introduction of tetrazole to the structure of the peptide sequence in some cases allows to obtain peptides with greater metabolic stability while maintaining its biological activity. Synthesis of tetrazoles containing octapeptide was performed in several stages. Initially, a linear peptide sequence was obtained by solid phase synthesis using the FMOC strategy. The removal from the polymeric carrier was performed with trifluoric acid in methylene chloride. Then the end in the peptide was reduced threonenol and removed permanent protective groups. Once it was shown that the tetrazole cycle doesn't have a significant effect in the process of peptide sequence. The possibility of synthesis of tetrazoles containing peptides can be used in the development of new drugs. Tetrazole-containing complexes of platinum group metals have proven their effectiveness as potential cytostatics and are promising objects of medical chemistry. Among various tetrazole derivatives, tetrazolicic acids pay special attention. These compounds can be considered an analogues of natural amino acids in which the amino group is replaced by a tetrazolide fragment. Compounds of transition metal ions with such ligands may have optimal solubility, participating in various intermolecular interactions and exhibiting biological activity. In this, so we synthesize a series of tetrazole acetic acids containing, and while their derivatives and then used as ligands in the synthesis of palladium-2 and platinum-2 complexes. Synthesis of tetrazolyl acetic acid derivatives was performed by alkylation of 5R tetrazoles with ethyl, followed by hydrolysis and separation of corresponding regioisomers, as well as presidium of the ethyl cyanacetate nitrile group, followed by hydrolysis and alkylation. In addition, we produced a series of amides. Synthesis of tetrazoles containing trans complexes of palladium-2 was carried out by direct interaction of tetrazolyl acetic acids with palladium chloride in 1 molar hydrochloric acid. The structure of the complexes was confirmed by X-ray analysis. It's worth noting that tetrazolyl acetic acids having in their structure endocyclic nitrogen atoms as well as oxygen atoms can act as both monodent and bident ligands. However, in all the complexes we studied, tetrazoles participated monodently in the formation of a coordination bond with metal. Coordination was carried out only in the involvement endocyclic nitrogen. During our study, in the course of the study, we found that the addition of alcohols to the reaction system leads to the etherization of the carboxylic groups, which is a convenient method of obtaining trans complexes of palladium-2 with the corresponding ethers of tetrazoic acids, the structure of which has also been confirmed by monocrystal X-ray analysis. In general, speaking of the platinum-2 complexes, it's worth noting that the configuration of the resulting complexes largely depends on the reaction conditions. Thus, the interaction of 2-alkyl tetrazole 5-yluric acids with potassium tetrachloroplatinum at room temperature allowed to obtain the trans complexes of platinum-2. Reduction of temperature by to 4-6 degrees Celsius also made it possible to identify cis isomeric products. Addition of ethyl alcohol to the reaction system resulted in the etherification of ligand and obtaining a complex with the participation of the ethyl ether. X-ray analysis has shown that even in the case of platinum-2 complexes, their coordination is also carried out on the endocyclic nitrogen atom in both trans complexes and cis configuration complexes. In order to study the influence of reaction conditions on the complexation, the study of interaction of acids with potassium tetrachloroplatinate was carried out. We recorded NMR spectra of reaction mixtures at certain intervals. In the course of the reaction, we recorded a decrease in the intensity of signals corresponding to the chemical shifts of protons in the initial 2-alkyl tetrazole 5-glucose acids, as well as the emergence and growth of signals corresponding to the protons that make up the complexes. The dependencies of normalized integral intensities of proton signals on reaction time were obtained. In course of the study, it was established that at the first stage there is hydrolysis of potassium with the replacement of chloride ligand on the water molecule. Then the first molecule of tetrazole replaces the water molecule with the formation of monosubstituted complex, and then there are parallel competing reactions with the formation of trans and cis isomeric products. Using these equations, reaction rate constant were determined. It can be noted that in general all reactions are at comparable rates. In order to determine the inhibitory effect of the chlor, the study of kinetics of the first stage of complexation was carried out. It can be seen that the D-chlor slows down the process of complexation by almost 2 orders. The presence of chlor in the reaction system also slows down the complexation, but to a lesser extent. We also described the study of thermal stability of the obtained complexes by the method were obtained. The study of thermal stability of the obtained complexes showed that the obtained compounds are thermally stable, at least up to 120-150 degrees Celsius, and also the mechanism of thermal decomposition is similar to the mechanism of decomposition of tetrazolyl luxose acids, these ligands. If we talk about the biological activity of the obtained complexes, we primarily consider them as potential cytostatics. As we know, the main target of anti-cancer drugs based on metal complexes is a DNA molecule. Transient metal complexes can bind to DNA both through non-covalent interactions such as intercalation, Faro binding, and covalent interactions. A specific type of binding can be determined by physical and chemical methods such as UV spectroscopy, circular dichroism. The analysis of UV spectra of DNA solutions show as well the UV is containing containing tetrazoles. In the latter case, the effect is observed in some case by a beta-chromic shift. This indicates the interaction of these metal complexes with DNA. At the same time, this type of spectrum change allowed us to exclude the type of interaction intercalation. Quantitative efficiency of the interaction of metal complex with DNA can be estimated with the help of binding constants. It's worth noting that obtained values of binding constants are in the range effective for binding to DNA and are consistent with similar values for known cytostatics. The circular spectra of DNA solutions in the presence of palladium and platinum with ethers demonstrate the same character of changes. The increase in the concentration of the metal complex leads to a significant decrease in the intensity of both negative and positive absorption bandwidth. Such changes may indicate the interaction of metal complexes with DNA on the mechanism of Faro binding. The melting point of the DNA was also determined to measure the efficiency of interaction between tetrazoles complexes and DNA. In all cases, the addition of metal complexes to DNA solutions caused an increase in the DNA melting point by more than 8 degrees. This indicates a strong stabilization of the double helix caused by the interaction of metal complexes. In addition, the influence of complexes on the viscosity of DNA solutions was studied. The data obtained indicate that the addition of metal complexes to the DNA solution caused a decrease in the viscosity of the solution connected with a decrease in the volume of DNA. Such changes are not typical for intercalation. The study of the ability of tetrazoles containing complexes to interact with plasmide, which is native in the ring superspiralized form, was carried out by gel electrophorus method. The data obtained indicate that metal complexes can change the electrophoretic mobility of the plasmid. At the same time, the formation of single-chained ruptures and the formation of an open-chain form of plasmid cannot be ruled out. Thus, tetrazoles containing complexes can change the tertiary structure of DNA. In order to determine the type of interaction between tetrazole complexes and DNA, molecular docking of the complexes was carried out. By results of calculations, the highest affinity is observed at binding of metal complexes with a small DNA furrow. It's known that palladium complexes in aqueous water solutions are rather quickly subject to hydrolysis with the replacement of correlating atoms with water molecules. Taking into account this fact, the hydrolyzed form of the tetrazoles containing complexes with DNA was also simulated. In this case, the changes in the free energy of Gibbs testifies the affinity of the metal complex DNA increases significantly. It is known that serum albumin is the main transport protein for substances in the blood circulation system. The efficiency of interaction of metal complexes, serum serum albumin was studied with UV spectroscopy and fluorimetry. In the case of adding complexes containing ethers, amides of tetrazoles acetic acid to protein solutions, a change in UV spectra was observed, as well as a decrease in the intensity of fluorescence. This evidences the interaction between complexes and albumin. This interaction leads to conformational changes in the protein structure. Using the Scatchard equation, the binding constants between metal complexes were determined. The obtained values of binding constants are in the range which is considered effective for the performance of albumin transport functions in the blood flow. Molecular docking was carried out to determine the most probable sites of metal complexes binding to albumin. The results of the calculations showed that the most probable binding site is a subdomain a cavity around tryptophan 213. Considering tetrazoles containing complexes as potential cytostatics, it was important for us to study their anti-tumor activity. Studies have shown that tetrazole acetic acids and complexes with their containing them do not exhibit anti-tumor activity. However, they exhibit cytostatic activity comparable to that of reference cisplatinum. The study of antibacterial activity of some complexes with the amide of tetrazoles acetic acids has shown that these metal complexes exhibit significant antimicrobial action, while palladium complexes were more active than platinum ones. Thus, the following conclusions can be drawn as a result of our work. A number of tetrazoles were studied, including a new effective metal-promoted approach to the formation of the tetrazole cycle, optimization of the methods of synthesis, tetrazoles with the use of microreactors, and synthesis of several series of tetrazoles for biomedicine, including analogues of the endogenous biological molecules and known drugs. Mechanism of interaction of modified tetrazoles with the most important biological targets were investigated by experimental and theoretical methods. Bioscreening of the obtained tetrazoles for different types of biological activity was carried out in vitro to identify the most prominent candidates. Presidium of the other conclusions you may find in my thesis. Thank you, Elena. If no one has, does anyone here have questions? Members of the dissertation board. Dr. Ninaidenko, do you have any questions? If possible, I would like to ask a couple of questions. You have a very interesting section dedicated to synthesis, and you said your aim was to increase the metabolic stability of this compound. What are your findings? Have you discovered anything significant about metabolism? Indeed, my aim was exactly this. If tetrazole cycle affects assembly of peptide sequences, and my second aim was to measure metabolic activity. Right now we are still negotiating with biologists, and well, right now the data is not available yet. And if possible, I would like ask one more question. In case of palladium and platinum, you observed there was a difference in coordination of nitrogen atoms. Can you make any predictions, or how would you explain these differences? The matter is in palladium, case of palladium-2 and platinum-2 complexes, there was no difference. We found no difference in coordination. Maybe I'm wrong, excuse me. In trans and cis configurations acted in the same way. And same is true about palladium, about the palladium complexes. The coordination mechanism is the same. Dr. Ninaydinka, are you satisfied with the answers? Yes, I am. Does anyone else have questions at this point? Nobody has further questions. Let's listen to the reviews of the members of the Dissertation Board, because since there are no external reviews, let's read out the reviews of the members of the board. Hello, dear colleagues. Hello. The thesis of Elena Popova is dedicated to compounds with tetrazole fragment. Tetrazoles are pharmacophores, which became common not long ago in 1980s. They became widely used, and today this branch of chemistry is developing very quickly, and a list of preparations submitted by Elena Popova these are all relatively new preparations, and the tetrazole chemistry is very relevant, and not all the aspects of this field have been studied. Developing active compounds, the problem should be addressed very carefully. Tetrazole complexes, tetrazole fragments, introducing them into biological active molecules, natural compounds or their analogs. And third was testing while their biochemical and pharmaceutical characteristics. So these three components go together. Unfortunately, Dr. Popova covers all these three issues, which makes it a very valuable piece of research. That's why relevance of Dr. Popova's thesis is obvious. Let me list the applicant promoted new metal promoted method for obtaining tetrazoles, studied kinetics and mechanisms of forming tetrazole cycle in a microreactor, studied applicability of different methods of introducing tetrazole fragment in natural compounds, obtained new tetrazolyl analogues of amino acids, peptides and nucleosides, measured antiviral activity on the new tetrazolyl analogues, obtain new complexes of platinum and palladium and their derivatives, and measured and described peculiarities of their interaction with synthesized albumin. Also measured anti-proliferative activities and antibacterial activities of tetrazole-containing complexes. These results have great practical value, as the author suggested two effective and safe methods of tetrazole synthesis: metal-promoted reaction and microreactor. Also should be noted that a number of new compounds, analogs of biomolecules and well-known medications which have significant potential as active substances. Dr. Popova demonstrated good command of different methods of synthesis and analysis of organic and complexes, transition complexes. She used many more contemporary methods, which evidence shows reliability of her results, and with the following conclusions can be made. Yet, I have a few comments and questions. When working on the metal-promoted, you use platinum-2 and platinum-4, though can also activate nitriles. Did you try to have to study the possibility of palladium promoting synthesis of tetrazole? Okay, let me read out my question. My second question is, so this is a comment, not really a question. In the literature overview, it places a strong emphasis on the biological activity of tetrazoles. Out of 75 pages, more than 60 pages are devoted to this very issue, whereas only only 13 pages are dedicated to the physical-chemical properties of tetrazoles. It seems to me that more attention should be paid to the chemistry of tetrazoles. This is a comment, not really a question. My next question: when comparing the alkylation rate of in a capacitive reactor in the process in a microreactor, it becomes clear that a capacitive reactor, the reaction is in the diffusion region, where the rate is determined by the interface transfer of reagents. The advantage of the microreactor is the better mixing due to the formation of turbulent eddies. But it remains unclear whether this process passes to the kinetic region. If this is not the case, then eddying make the process even more efficient. So how did you test this? This is my question. On page 119, you say it can be seen from the data of SAR and specific rotation in the course of presidium racemization is not observed. The data of molecules cannot indicate the absence of the value of angle for the connection is not described early in literature. Have any other evidence been obtained that amino acids are not partially cleared for amino acid presidium? Which has not been described earlier. You don't know what's specific rotation angle. So my question is, what other evidence do you have that amino acids are not partly cleared for amino acid presidium? My fifth comment is when discussing the mechanism of interaction with tetrazole and calcium platinate leading. As you say, the reaction goes in several stages. Then the tetrazole molecule replaces the water molecule to form the platinum chlorine ligand complex. This assumption is very likely and well considered as described in literature. However, the author further suggests that the next stage of the ligand exchange goes differently, not through the intermediate formation of an aqueous complex, this assumption runs counter to the previous assumption of the author, as well as to the experiment data. Well, this is a minor comment, but it's included in conclusion number 8, and it should be excluded from the wording of conclusion 8. The author places emphasis on electronic properties. Methyl isopropyl butyl substituted tetrazoles. The author believes that the difference in reactivity is related to the electronic effect. In reality, the effect is rather sterile here, since the difference in electron donor capacity between the substances is significant. But most importantly, the electronic effects does not explain the much larger difference between the third butyl isopropyl substituent. Moreover, this difference is manifest. Therefore, the statement about the donor's ability should not be included in your conclusions. And some minor inaccuracies and comments to execution, but these comments do not affect the overall high opinion of the study. The study, by the amount of experimental work, this is a outstanding piece of writing. The number of articles published in 24 presentations at Russian and international scientific conferences, a number of patents obtained by the degree applicant. The contents of the thesis and personal contribution of the applicant. The author quotes, make her quoting system as well. So I may say this is a valuable scientific study, a complete piece of research, tetrazole containing analogues of natural compounds and well-known which can improve synthesis of new biological active substances. I think the thesis of Elena Popova meets the requirements set forth in the order on the procedure for awarding academic degrees, and the applicant deserves being awarded the degree of Doctor of Chemistry. Article 11 of the above-mentioned order has not been violated. Thank you. Thank you, Dr. Bayarsky. Let me answer your questions. If we studied palladium-promoted tetrazole synthesis, so yes, we studied the metal-promoted the effect is due to the fact the choice of platinum was due to the fact that earlier in a number of studies it was shown that the reactions of successful when using trial complexes of platinum. This cycler addition of nitrons to the coordinated neutrals was described. For neutral complexes of other metals such as titanium, molybdenum, tungsten, etc., such effects was not observed. However, the interaction of azides with coordinated neutrals was not investigated. It was important for us to do this in order to show that acceleration of the formation of the tetrazole cycle in the transition of such metal-promoted reactions is carried out and coordinated tetrazoles can be obtained in very mild conditions. With palladium compounds, we have not conducted such studies yet, although this topic really deserves attention. Comparison of accelerated natural platinum and palladium is especially interesting. However, it should be noted that working with palladium compounds, especially in quantity measure, can be more difficult. For example, the palladium complexes are more liable, and there may be a competing reaction with the formation of coordinated azides. So this is interesting, but we have not studied this yet. Speaking to answer your second comment about the literary review in my thesis, it was entitled Tetrazoles for Biomedicine, and the name of the review is Tetrazoles for Biomedicine, and the fact is that the chemistry of tetrazoles, their methods of obtaining and reactivity has been described quite well in several important works. For example, a major study by Trifonov, Ostrovsky, Koldovsky. In 2016, a book was published with my participation, Advance in Heterocyclic Chemistry of Tetrazoles, where issues related to tetrazole chemistry were comprehensively described. Despite the obvious importance of tetrazoles in medical chemistry, there's been no comprehensive study of this topic. Well-known publications either summarize individual aspects of biological activity or treat activity as a supplement to the description of the methods of synthesis of different types of tetrazoles. In my review, I tried to summarize the most popular relevant hypothesis explaining the nature of biological activity of tetrazole-containing compounds, and try to identify trends and prospects for the use of tetrazoles in medical chemistry, mainly over the past 10 years, through specific examples. So this is the so we published a recent review called Tetrazole for Medicine. To answer your third question, so microreactor, and if there is any relation to specific conditions, and if we studied this, calculation of 50 tetrazoles was carried out in heterogeneous system. And as Vladimir Pavlovich rightly noted, the reaction is in the diffusion area, and the reaction rate is determined by the diffusion rate. We have not studied the kinetics of this heterogeneous reaction, since this process is a set of chemical reactions. The kinetics of heterogeneous process depends on many factors, and therefore the quantitative characterization of the process is complex. Well, I would like to say that the Taylor mode of liquid flow and mass transfer in this mode has its own specific features. And at the moment, only a small number of articles has been published on this issue. So this, some papers, some articles published by our colleagues from St. Petersburg State Technological Institute from the Department of Chemical Biochemical Process Optimization under the guidance of Professor Abiev. And together with our colleagues, we conducted this work. So we started this, and they continued what we have started, carried out determination of the regularities of the intensity of mass strength under conditions of so they obtained suggested interest in models, and demonstrated that mass transfer depends on the length of microchannels. So these processes have been studied. I would also like to add that this work is still in progress. Olga Nesterova, under the guidance of Professor Ostrovsky, who presented her thesis 1 year ago, they investigated the efficiency and safety of alkylation of very sensitive sodium salt, a 5-nitrotetrazole, which is a very sensitive substance. Please, let's stick to the schedule. The next question. So, indeed, I agree with Vadim Pavlovich. Indeed, the X-ray analysis of a cannot. So this is, I accept this comment. And indeed, the X-ray analysis of a zinc cannot unequivocally indicate the absence of racemization. However, I'd like to say that the reaction center is remote from the chiral center. In addition, the alpha amino group is protective by a protective group of urethane type, which is known to be effective in protecting against racemization. We also used a tetrazoline analog in further synthesis of peptides, and at each stage we controlled with, and if we witnessed racemization, we would observe formation of diastereomeres, which we did not. about the mechanism, the interaction mechanisms, why we think at this second stage, the first stage is classical replacement, and then the second stage, what the molecule is replaced, why we didn't take this stage into consideration. Here, indeed, this statement was maybe too strong. And maybe
как бы опирались на отсутствие каких-то
that because since we did not observe additional signals in the NMR spectrum, and this concentration of resulting products, and if we noted acid hydrolysis at the second stage, we would have observed additional signals. Maybe the process was too fast, but platinum hydrolysis is not very fast. The rate constant of acid hydrolysis of tetrachloroplatinum is 3.65 seconds. So the only suggestion I can make, it was too fast, and the rate was too fast and could not be detected. And about the mechanisms, we believe that the difference in complex formation and speed of reaction, we explain this by the donor effect, not by the steric factors. If the steric factors were actually present, the highest speed, the steric effect is hardly predictable. The replacement in the second position is far from the reaction center, fourth nitrogen atom. So this so the constants are quite close, yet there are some differences, and that's how we explained this. Dr. Boyarsky, are you satisfied with the answers? And yes, about the I accept your comments about misprints. Dr. Vasilyev, can you please read your review? The relevance of your work is explained by the tetrazole is an important substance with important properties, is relevant for not only for chemistry but medicine, and so this is a very impressive piece of research. For example, in the Russian part of the is 287.
Это не то, что Google переводчики, Елена Александровна еще и показала знание английского языка. Значит, по итогам работы опубликовано больше 20 статей, из них несколько публикаций в журналах из первого квартиля, и в том числе 5 обзорных работ. То есть это редкая докторская диссертация, содержит еще, и было время еще и эти работы все осмыслить и сравнить с имеющимися в литературе аналогами. То есть это большое достижение. На многих конференциях, больше 20 конференций Елена Александровна докладывала свою работу, то есть она прошла серьезную апробацию. Значит, в самой диссертации в литобзоре рассмотрены различные аспекты химии тетрозола, строения, их свойств. Ну и основной текст, касающийся обсуждения результатов, Елена Александровна сегодня доложила. Новизна научная и практическая значимость не вызывают сомнений.
The relevance of the work is beyond any doubt. The synthesis of tetrazole and the importance of the biological activity, practical value of the work in describing synthesis methods and of biologically active substances. Now let me proceed to my comments. I only have three. I would like to only have three comments. She describes good So that will make the work even more valuable. This is my first question. And second question about biological activity. The tetrazole activity. Is this the right question to ask? And my third question is about racemization of the tetrazolesic acids, pure acids, obtain pure acids, and how can this be explained? In general, these comments do not affect the overall high opinion of Dr. Popova's thesis, and think she deserves an awarded the degree of Doctor of Chemistry. Thank you very much, Dr. Vasilyev. Let me answer your first question. If free tetrazoles can be obtained, yes, free tetrazoles can be obtained by adding strong mineral acids. It was important for us to quantify the metal propagating effect of platinum, and we focus on this. However, this method cannot be considered sound method due to the high cost of platinum compounds, but the propagating effect is quite prominent. Let me answer your second question. If activity can be related, tetrazole containing complexes, we confirmed experimentally that tetrazoles do not have activity. Both components are necessary for this cytostatic effect, and the complex acts on biological objects as a whole. And your third question about racemization. In fact, racemization of initial amino acids and the degree of racemization, this is a very important issue, and the issue of racemization mechanism should be needs further study. However, we don't rule out that the mechanisms of racemization may go through formation of the five-membered follow the classical mechanism, which has been well described. For example, through the formation of five-man heterocycles, such as lactone cycle, in the case of the reaction of acylation of amino acids in the presence of the base. So flat heterocycles are formed with an active hydrogen atom. Proton approaches the cycle on different sides, and that way racemization happens. So we believe that this mechanism can also happen here. Dr. Vasilyev, are you satisfied with the answers? Dr. Ivashkevich, and please read out your review. Yeah, I'm very honored to take part in this session of the dissertation board, and there are many reasons for this, the main reason being that we have been working with scientists of leading St. Petersburg universities, such as the Technological University and St. Petersburg State University. I defended, or actually redefended, my thesis at the Technological Institute here in St. Petersburg, and then we have worked very closely together with our colleagues of the Technological University to work on, after the Chernobyl disaster. And in year 2001, in this very hall in St. Petersburg, one of the most famous tetrazole researcher of tetrazoles. Am I wrong? Did I say something wrong? In 2001, in this hall, not here, was it not here? In the technological university, did it happen? Yes, I know you were the consultant, one of the main authorities on tetrazole, Dr. Gaponik, and so we have worked together with Dr. Boyarsky, and I've dedicated my entire career to a study of tetrazoles. This is a high-quality piece of research, very well and clearly written. In the beginning of her presentation, the applicant states in which direction the study of tetrazoles should go, and this is very accurate. So including about 15% of the most common medicine, much more resistant to metabolism. So this will allow to create a medicine with prolonged active cycle. I don't know. I have many comments, but they are not. So maybe should not go. I'm sure the applicant has answers ready. This work is a good example of an outstanding example of interdisciplinary study. Just look, it includes organic chemistry, bioorganic chemistry, non-organic chemistry. Pharmacology, biomedicine, etc. And this is good, but I think maybe I'm. Please do not. Maybe I'm very arrogant. Let's see which specialty says organic chemistry, and the work is only 20-25% is dedicated to organic chemistry. And since the university has the right to award the academic degrees universities, I think the university should pay more attention to this. Doctoral thesis can cover several specialties. Apart from that, I don't have any comments, no further criticism. I'm very satisfied with this thesis, and I think the applicant deserves the degree of Doctor of Chemistry. Dr. Popova, can you answer? Thank you very much, Dr. Ivashkevich. Let me take your comments one by one, if that is necessary. First, says that tetrazoles really found in nature. As we before we used to say that before, and tetrazoles never occur in natural compounds. Yet there was one publication which says that tetrazoles some bacteria are present. But after that we changed the wording. Wording here. So this is not crucial. This comment is not very important. About your second comment, that the aim of the paper is too general, I accept your criticism, but I would like to say that we consider the process of acidation process as a whole, and this method requires long exposures at high temperatures and therefore this method needs to be optimized, in our opinion. The wording is explained by this. About your third comment, I accept your comments. About the fourth comment about our list of reference literature, I also accept. About your fifth comment about subtitle tetrazoles for biomedicine. Biomedicine, also called theoretical medicine, is a branch of medicines that studies from a theoretical point of view human body. So maybe medical chemistry will be more appropriate. Well, maybe biomedicine was an incorrect term to use, yet this term is now used very widely, including in conjunction with the term medical chemistry, and it includes research not only in theoretical medicine but also covers issues related to the development of pharmaceutical and biopharmaceutical products. But your sixth comment about the wordings, I agree, the wordings were not correct. Seventh comment about reference number 32, I accept your comment. Even more so, the Dr. Iwaszkiewicz co-authored this article. Your comment number 8, that molecular docking would be a more accurate term. I accept your remark. Ninth comment. Conclusions to section 1.5 somewhat contradictory. Addition of metal halides may contribute to the release of free hydrogen. It's not clear how. So what we wanted to say here, in some cases, metal halides have been used. For example, zinc salts formed and a weak base. And in this case, the salt will act as an acid and will displace hydrogen from its salt. And Sharpless also observed that. That's what we wanted to say here. The comment number 10 about the definition of 5R tetrazoles. I definitely agree. Number 11 about the name of conclusions to section 1.2.1.2.2. Comment number 12 about the conclusion and recommendations. Recommendation. This is not an accurate, very accurate expression. It would be more correct to use another expression as described earlier, and you refer to a monograph. So we certainly do not claim authorship, and here we were in this context we were interested in racemization, because this work is a part of another major project on peptide synthesis. And of course, we are very well familiar with these works, and I actually make reference to these works in my thesis, and of course we don't claim authorship. Conclusion 13, on conclusion 1, comment number 13, was more to specify each tetrazoles. I absolutely agree with this comment. Thank you. Dr. Iwaszkiewicz, are you satisfied? Okay, Dr. Ninaidenkov, please read your review. I was very happy very pleased with this thesis. I'm very pleased with this thesis. I think it's a very interesting piece of research. Why I liked this thesis? This is a very homogeneous, it's characterized by a very comprehensive approach, which includes chemistry, kinetics, coordination, chemistry. In her work, Dr. Popova demonstrates unique properties of tetrazoles. We have already discussed this today. the great number of medical products are based on tetrazoles. I'd like to say that there are what is nice is the contribution of St. Petersburg School of Organic Chemistry to this field is very significant. And in literature we may come across many reviews, medical, first of all in medical chemistry of tetrazoles, published by our St. Petersburg colleagues. We like to quote in our papers on tetrazole chemistry. The relevance and comprehensive aspects of the work I already mentioned. What I particularly liked about this thesis and to save your time, let me go straight to my comments, which are very few. No matter how good a thesis is, every thesis contains a number of misprints and inaccurate wordings, and here Dr. Popova could not avoid these. I read this thesis very carefully. I read the experimental part very carefully, which is very well written, as well as the paper, or the whole paper. And a few comments. It was not necessary in spectrum, 2 decimal places that was not necessary. And if you have data for platinum spectrum, is not available for all platinum complexes, should be given. Yet these are all very minor and insignificant comments, which do not affect my overall high impression of this thesis, which, in my opinion, fully deserves, because of its relevance, novelty, and scientific significance, level of publications. Conclusions meets the requirements to doctoral thesis, and the degree applicant, Dr. Elena Popova, in my opinion, fully deserves being awarded the degree. Thank you very much. Dr. Bell, thank you very much. Dr. Ninarnikov, I agree with all your comments about misprints and abundance, and for not all platinum complexes we produced spectrums. I accept all your comments. Thank you. Dr. Ninarnikov, are you satisfied? Yes, with the answer. Yes, I am. Okay, now let me read my review. Heterocyclic compounds play a major role in compound medical chemistry, agricultural chemistry, and industry. But half of all medical preparations contain tetrazoles. That is why developing they play a special role in medical chemistry, because tetrazole-containing compounds have very diverse properties and biologically very active. Because of that, the thesis by Dr. Popova, dedicated to new synthesis methods, properties and biological activity in new tetrazole-containing molecular system, is relevant and has practical significance. The main content of the thesis is dedicated to developing effective and safe methods of tetrazole synthesis, includes nitrosylyl derivatives of natural compounds, biologically active substances. They study their biological activity and mechanisms of interaction with biological targets. Novelty of the thesis is in development of the method for 5R tetrazole cycle, acidation organoids coordinated with platinum-2 and platinum-4, synthesis of tetrazolyl amino acids, peptides, and nucleosides. Series of thymidine derivatives containing tetrazole fragment. In the study of kinetics of forming tetrazoles in a microreactor, which is a very important field today. The study of biological activity of new tetrazole-containing compounds, and how they can be used in different spheres. The thesis of Elena Popova as a traditional layout consists of introduction, literature review, discussion of results, experimental part, conclusion. It's 287 pages long and has 421 references, contains 221 references. The author covers the thesis is well written, very logical. The author has analyzed literature and many compounds, their structure and reaction conditions and efficiency. Well, the conclusions are based on many experiments which can be replicated, and the structure of obtained compounds seems to be reliable. Obtained scientific results were discussed from the view of modern organic and medical chemistry. The practical value of the results is in developing efficient and safe methods for tetrazole synthesis with metal-promoted approach, using with the use of microreactors, producing tetrazole derivative endogenic molecules, as well as medical preparations such as cisplatin, which can be seen as promising biological active substances. I don't have any significant comments. The thesis is well written. List of illustrations illustrates synthetic biological research. There are few misprints, yet the author should avoid inaccurate wordings such as increasing prolonged and asymmetric hydrogen atoms for synthesis of new crystals. Should be the author should give a melting temperature for all new compounds. Describe their composition and use abbreviation. Give abbreviation. Use only one language for abbreviations. So experimental value, not only accurate ion weight. A neutral molecule would be valuable to evaluate scalability of synthetic solutions such as microreactors and metal-promoted synthesis. These comments do not affect the overall high opinion of the thesis, and the results of the author's experiments are beyond any doubt. The results were published in 19 articles, peer-reviewed scientific publications, including the list approved by the Ministry of Science of Russia, and included in the international citation bases such as Web of Science and Scopus. The publications describe the results which were presented at international conferences. The thesis of Dr. Elena Popova, synthesis properties and some types of biological activity of tetrazoles, meets the main requirements set forth by the order number 6821 on the order of awarding academic degrees at St. Petersburg State University, and degree applicant Popova Elena Alexandrovna deserves being awarded the academic degree of Doctor of Chemistry, specialty 020003, Organic Chemistry. Thank you very much, Dr. Khlebnikov. I absolutely agree with all your comments, and you didn't ask any questions. Does anyone anyone present here wants to speak? Since there are no volunteers, nobody's willing to speak, let's give the floor to the academic advisor, who has 3 minutes to give his opinion of the degree applicant. Dear colleagues, Dr. Popova, despite her young age, she's done a lot as a scientist, as a scholar. She started her research as a second-year student of the Technological University, and over this period she achieved impressive results. It happens so that in the course of her research, we constantly ran into complex problems and challenges which we had to address, and there was a number. And this multidisciplinary approach, which was mentioned here a few times, and there was which called for a discussion if the thesis is in organic chemistry. As such, the author describes various properties of the compounds and how they can be used in different spheres, what their practical use can be in different processes where they have not been used before. I would also like to add that Dr. Popova, in addition to her scientific career, has devoted much attention to education. Her students are present here. She herself is a leader of a scientific group which conducts research in various fields of organic and non-organic chemistry, and in addition to being a professor at the Technological University, she worked at the Chemical Pharmaceutical Academy. These are very diverse spheres and very diverse universities, very different. The universities are very different. In addition to that, Dr. Popova, since 2011, has devoted much attention to pharmaceutical companies, and I think I succeeded to bring her back to her research thanks to grants available at St. Petersburg State University, which she won in 2015. So she was able to earn salary comparable to that she was offered by a pharmaceutical company. I am very proud such a major piece of research turned into a doctoral thesis, which we are reviewing here today. I would also like to add that though Dr. Popova's thesis has many sides and many aspects, but if we look at its specialty, organic chemistry, I personally think that the major part of this thesis is dedicated to organic chemistry and fully meets the requirements, though of course it covers many different areas and many different fields as well. I support the degree applicant, and I recommend the dissertation board to award a doctoral degree to the applicant. Thank you. Now time has come for the discussion on awarding, on not awarding. So I please stop broadcasting for this period, and I am kindly requesting everyone present here and all non-members of the board to leave the meeting room for this period, and I will inform you when the discussion is over. Dear colleagues, time has come. The most important moment of our meeting has come. I put the awarding of the academic degree to the open individual voting. Let me remind you that the decision of the Dissertation Board shall be considered positive if more than a half, but not less than 3 members of the board vote for. In accordance with Article 23 of the procedure for awarding academic degrees at St. Petersburg State University. Dr. Boyarsky, I am for awarding a degree. Dr. Vasilyev Alexander Viktorovich, I am for awarding the degree. Ivashkevich Oleg Anatolovich, Dr. Ivashkevich. Ninaidenko Valentin, I am for awarding the degree. I am also voting for. I would like to join my colleagues. Thus, dear colleagues and guests, let me announce that out of 5 members of the board participating in the meeting, 4 members voted for, nobody voted against, and nobody abstained. The decision on awarding the academic degree of Doctor of Chemistry, Specialty 020003 to Popova Elena Alexandrovna has been passed. I congratulate you, Dr. Popova, and let me, you have an opportunity to thank your colleagues for their support. Thank you very much. First of all, I would like to thank Alexander Feodosevich Khlebnikov and other members of the Dissertation Board. Dr. Boyarsky, Dr. Vasiliev, Dr. Nagin-Doveshkevich for such careful consideration and their valuable comments, which I'm going to use in my future work. And I would like to thank my colleagues and my academic advisor, first of all, Dr. Professor Trifonov and other colleagues of the Department of Chemistry of Natural Compounds, Professor Protas, Olga Mikolajchuk, and my colleagues in other laboratories and other universities, Professor Ostrovsky, Dr. Pavlukova and other colleagues for working with me. Thank everybody, and I would like to especially thank my family for their support, for their kind assistance. Thank you very much, everybody. I declare the session closed. Thank you for your participation. Please stop online broadcasting.